Good morning, guys. So let's continue with the online class today. Before moving to a different topic, let's finish a couple of concepts that we had that we have been working with the previous class. So remember, guys, we were talking about commercial credits, and one of the ways, of course, we discuss store one, and then we discuss store two. Then what we did is we first found what is called the market price. And once we have the market price, what we try to do is for each individual store, we find the payment one and payment two, all this based on flat method. Okay, so what is a flat method, guys? Remember, it's simply simple interest rates. So it's the use of simple interest rate, right? And once we have the payment, is when we use the market price, and then we compute what is called the cost of capital, right? Cost of capital one, cost of capital two, and then we select the smallest of this one here. Now, as part of the example, we also had a third alternative that was a bank. Okay, a bank works regularly in general, almost always, with component interest rates, right? So what is also interesting is that component interest rates, guys, is more or less like computing the mortgages. Right? But imagine, so this is related to this one here, but imagine the following. The principal that you need is 100. Okay, so imagine that the interest, let's assume per period, is equal to 2%. And imagine, guys, that you have a fee that is equal to 0.5%. Okay? And assume finally that perhaps n is going to be equal to 12. Right? So if we do this in Excel, we're going to find a payment. Okay, and remember this payment, for this payment, you don't consider the fee. The fee is only to estimate the cost of capital. Right? But now we have two situations here. And let's try to understand that. The first case is very obvious. So you are going to receive 100, and then you're going to make 12 payments. But you need to bring your what is that, 5 cents. That corresponds to the fee. Got it? And then remember, for the payment, we ignore we ignore this fee, and so we simply compute the payment as regularly in Excel. However, what happens if you tell the bank, you know what, I don't have this money here. I want you to finance this money. Okay? The relevant question here then is, okay, how much money you're going to request to the bank? One obvious answer is, you know what, if I want the bank to lend me this one here, simply my loan should be 100.5, right? That's the logic one. If we do that, imagine, guys, if we do that, so we say, I want to include the fee in my loan. Now, if we want to include the fee in the loan, this basically means that the intuition says, okay, you know what? Give me 100.5, and then this payment here now, as soon as I'm including the fee as part of the principal that I will get, so this payment here will include this number here. Okay? So this looks good. And we have 12 periods. Now, what is interesting, and just to tell you something, let's assume that the amount of money that you need is 100. Okay, so you want to buy I don't know, perhaps an application or anything, and you need 100. Okay, so you need to go to the store with $100. Okay, So let's take a look at what happens in this case. What the bank is going to do is going to say, okay, you know what, you need to pay me the fee of 0.5. And I will deduct this fee from this 100 here. So let me find my calculator. Here. So what is the fee? What is the 0.5 of 100.5? If you do this times 0.01, we're not going to know this a lot, but it's going to be something like okay, so how do we compute the fee that I will pay? So the fee that I need to pay to the bank, so let's compute the fee, is going to be this amount, the amount that they are lending me, times the fee. So if you do this, guys, the number that you're going to obtain is that you need to pay 0.5025. You see, so of course, the amount of money is very small, but if you multiply this just by $10,000, so this is a significant difference. So this is the difference. So this one here will not provide you, because if you subtract 105 minus this number, what you end up having, so from here you can realize that the amount of money you're going to get is equal to 99.4975. So you see, this is smaller than 100, and you want your 100. Okay. So what is the correct way then? So this way here that apparently was correct, it is not correct. So the correct way of doing this, guys, is to compute. If you want to include the fee in the loan, what you need to include as a loan, so as a principal, is going to be the 100 divided by 1 minus the fee in percentage terms. Okay, so basically what I'm telling to you here is it should be 100, 1 minus 0.005. So this is equal to 100 divided by 0.995, and this is equal to I need to ask for 100.5025. Got it? Now, with this one, and then there are more decimals. And with this one here, guys, of course, again, remember that these payments now, as soon as I'm including the fee in the principal, so the payments now are going to be computed in terms of this number here. Got it? And then you have your 12 payments. But what is interesting is that from here, what you're going to pay as fee from this 125. So the bank, what it will do is they are not going to give you this amount of money. What they are going to subtract from this one here is the 0.5025, and then you end up having the $100 that you need. Okay, so this is the correct way to do it. What you do is you divide by 1 minus the fee that you're going to be paying, and then the amount of money for sure is going to get you exactly to the $100. So this is the correct way. Okay, let's try to do this very quickly in Excel. So it's 2%, 5 and 12. Let's open an Excel. Let me see. Okay, so let's do this. I will say the principal. The principal is, we said it was going to be 100. My interest monthly, we said it's going to be 2%, just to do it simple. My N is going to be 12. My fee is going to be 0.5%. Okay, and then the first thing you need to remember is that the payment, the PMT. So if I don't include this fee here, if I don't include the fee in my principal, the payment is going to be simply my PMT. Let's use the Excel formula. My rate is going to be this one. My number of periods is this one. My present value, I will say a negative 100, and then that's it. So this is what I need to be paying per month, right? And if you do your table, so let's say number, so we're going to have 12. We're going to have the principal. We have capital or amortization. We have interests. And then we have a PMT. And we are in the French method, constant payment. So this one here is going to be always this one here. It's going to be this one. So the number of payment is the number of quotes. No. It's going to be simply 12. This goes to here. The first principal is going to be the amount of money I owe. That the interest is going to be this one here times this one here, and we fix that one. Remember that? And my capital is going to be simply the payment minus the interest. My next capital is this one here minus the capital I'm paying. I'm amortizing. I copy these two here. And then from here, we should be able to run this. Remember, this number here must be equal to this number here. Okay. So in order to find, so where this fee enters is simply to compute the cost of capital. Okay. So when you want to analyze the cost of capital, so let's write this here, cost of capital. Here is where it enters. Perhaps I can move this a little down. Okay, so I will copy this. I want to have the principal. I need to discount the fee. So my principal is going to be this one here. My fee is going to be the principal times the fee. And so the net amount that I will receive, if there is no, if I'm not including the 0.5 in the 100, is going to be this one minus this one. And then what you create is simply your, again, let's do time. I will put it here. So times 0, 1, 2, etc. So we got 12. So in time 0, what I do is I receive a 90. So I receive this amount here, and then I simply copy the payments here. I copy the negative of payments because they are outflows. Remember that. So if we have the outflows here, and then what I do here to compute the cost of capital, I simply use the internal rates of return technique. Okay, so I simply lock all this part here, and here we go. So let's do with more decimals. So instead of paying 2%, you're going to be paying per month. It's the equivalent that 2% plus a fee of 0.5% is equivalent to a monthly fee of 2.08%. Right? So that's what is crucial. The fee does not enter the payment estimation if you don't want to include the fee into the principal. Okay? But now, so let's write this, not including fee in principal. Okay, so you're going to bring, when you go to a bank, you're going to bring your own 5 cents, right? And then you receive your 100. Now, if you want to include the principal, so let's put this like that. Now, if you want to include the principal, okay, so how this happens, how this works. Okay, so let me copy all this part here. We're going to modify this in there. So the first thing that you need to remember, guys, is the principal is not going to be any more 100. The principal is going to be this 100 divided by, remember, we did a formula in the previous case, 1 minus the fee. Okay, so now what I'm going to be asking, guys, is the 100.5 50.25. As soon as this is my new principal, take a look to my payment. My payment now includes this one here, because I have decided to include the fee, or I have requested the bank to include the fee in my principal. Okay? So here we go. I need to modify this one here. This is going to be this one. And also the interests are going to be modified. Yeah, well, it's the same, but let's just be consistent. It's going to be this one here. And here we go. You see, these two are the same, so we are perfect. Now, take a look to so what I need to do here is, this is 105. You see this one here, this is my principal that includes the fee. I subtract the fee, what I get, 100. Exactly what I need, my 100. If you do the opportunity cost is basically the same as this one here. Makes sense? So if you bring your money, don't bring your money, makes no difference, no significant difference, unless you're working with millions of dollars. In that case, it makes perfect sense. Okay, so let me do something. Let me save this one here. Okay, we'll save this later. Now, another topic that is really interesting, and that is time to cover here, is that up to now, guys, what we have been working with is with the French method. Okay, the French method is this method here. Is this method here, that you have constant payment. Okay. However, there is another method that is called the American method, or the constant amortization method. Okay, so let's do this very quickly. So what is the constant amortization method? Also called American method. Okay. How this works is very simple. So let's go back to my principal. I have a principal of 100. I have an interest rate per month of 2%. Just to make it simple, I have N of 12. And if we want, we can continue assuming my fee of 0.5%. Okay, pay in advance. Now, how the constant amortization works? Okay, the constant amortization works in the following way. What it means, constant amortization, is what we call capital payment. Remember, in the table that in the schedule of payments, the capital is always going to be constant. This one here is going to be constant. Okay, so how do we do this equal, or how do we make this constant? Well, very simple. What we simply is we divide the principal divided by n. So if my principal is 100 divided by 12, so basically I need to pay monthly. The capital payment or amortization is going to be 100 divided by 12. It's going to be 8.33. Okay, so this is going to be my constant payment. Now, how do we build the table? The table is the same. So we have let's consider a period or number. It's okay. We have again principal. Just to follow up with the previous example, I have capital. You know, you can include here interest after capital, but let's do this in this way just to follow what I've done before: interest and payment. Okay, so now what I will have is 1, 2, 3, and then we do this in Excel. So my principal is going to be 100 here. The capital always is going to be 8.33. So it's going to be 8.33. It's going to be 8.33, etc. So it goes like that. Now you compute the interest. So the first step is you fix this one, and then you compute the interest. So it's going to be 100 times 2% is going to be 2. And then the payment now is the one that is a formula. The payment is going to be basically this one plus this one. So I will have here 10.33. Okay, my next principal is going to be 100 minus 8.33. So what I will have here is going to be, my new capital is going to be 91.66 periodic. Great. Then you compute the interest for this one here. the principal is the same. So the interest for this one here now is going to be 1.833 periodic. And then the principal, the payment is going to be 8.33. So your payment is going to be 10.16 periodic. Okay. And that's the way. So what you can realize, guys, is that the capital is going to stay constant. The interests are going to start decreasing in time. And also my payments are going to start decreasing in time. So remember, the main difference in the French method is that the payment is constant and the capital starts increasing and the interest starts decreasing. Okay. So let's try to do this in Excel. And this is called the constant amortization method or the American method. So let's take a look to what happens into Excel. Let's use the one that we have been using. So let's take a look to this one here. So I will basically create a new file, a new tab, and I will copy this one here. Okay, so this is my French method. So I will call this is constant payment, or what is called the French method. And its American counterpart is going to be here. So we copy, oh yeah, let's copy all this part here. No. Okay, so I have the 100, 2%, the 12, the fee, and my payment is not anymore the payment formula. My payment here is going to be simply the principal divided by 12. That's my principal, always my principal, or my payment is going to, sorry, not my payment. My capital is this one here. Okay, because I want to keep my capital constant. So this one here, this formula here, is going to be now equals this one, $. So this means that always is going to be constant. And then I copy this one here down. And then here, these two is going to be, the formula is the same. It's going to be, let me move only this one here, is what is left as principal multiplied by the interest rate of the period. And here we go. So let's do this, all of them. Yeah, a lot of decimals because it's periodic, just to show you the periodicity. And then my payment, guys, is going to be that one that is going to be equal to the capital plus the interest. And then you copy, and here you go. You see, these two numbers, as usual, guys, needs to be equal. And what you can see here is the payment goes down. Payment goes down, and the interest goes down. Got it? Now, let me open a little more just to make some comparisons here. Let me copy also from here the cost of capital. Okay. So I'm in G. So the cost of capital, guys, okay, B3, so this is okay, and 95, okay. So my cost of capital was equal to 2.08, correct? So using the French method, this was my cost of capital. This is my payments. This is what I receive, etc. So I will copy again this one here, in here, just to compute the cost of capital with the French method. Okay, so this one here, let me see if this is correct. Yeah, this is here, this is here. This is what I received, the same as here. It's exactly the same as here. My payments are going to be different. My payments are going to be these ones here. And then if you compute the opportunity cost, so let me do a little more, just to take the difference. You see, which one has a higher cost of capital? Normally the American method. Yeah? You see the difference is mild, but guys, again, if you're talking not about 100, but you're talking about thousands of dollars, so the difference is significant. Okay, so if you are a lender, you like more this method. If you are a borrower, you like this method more. Okay, and in general, guys, this one here is a reference now. Yeah. At least in the USA, the loans are given in this method. So if you go and get a mortgage, what you get as a mortgage is basically based on this method. Got it? I think that with this part here, we should be okay. We should be okay with what we have to do in the previous class, and now we can move towards another example. another topic. So let me just give me 1 second. And let's save this one. Let me save this one here for 1 minute. This is what we did here, and constant. Okay, so we can go to a new topic now. Let me save this one and let's move. Okay, guys. So what is next in the class is something that is really interesting and more relevant now that we are talking all the time about inflation. Okay, so we're going to start discussing how inflation affects our analysis. Okay, how important is inflation? Now, what is inflation, guys? Is simply the increases of price, the generic increases of price of a basket of goods that we have, right? So, and that's crucial. It is not only the increase of prices on one, it should be in general. It's an increase of price of my basket, of the price of a basket of goods, okay? And that's the basic definition. So prices start increasing. Okay, now why prices increase? There's a generalized price increase. That's what the people define more or less inflation. Okay. Increase in prices. Okay. Normally of a basket of goods and services. Okay. So we use the CPI, for example, Consumer Price Index. That is basically creation an artificial basket of goods and services that represents the average individual in a country, and this is the number that we normally use. Okay. Now remember, the CPI, guys, is a number that's based on an average number of an average population, average individual in a population. Okay, so it's not necessarily the CPI, it's not necessarily the inflation that you're going to be using for your own businesses. For example, one example is that if you're in the airline industry, you don't really consider a lot about food. Of course, food is an important part of your cost structure, but most important for you as an airline is oil, for example. So you know what, you want to give more weight to oil in your basket. So what I'm trying to tell you is that the inflation, it is corporation specific, unless you more or less represent the average population. That's very strange in real life. Okay, so why inflation? So in general, and this is not for sure a class on inflation, but I just want to give you some insights of that. Why inflation? Well, what happens? What are the causes? We can have basically two main causes, or three indeed. So we have the demand side of the equation. So what happens when the people get more money? What happens if the governments start spending more? What happens when there are more salaries? What is going to happen normally, guys, is that or more salaries or more labor. Remember, this is what is happening now. We have been after coronavirus, the labor has decreased by a lot, and now labor is coming back to the market. So there is more people gaining money again, and as soon as the demand for labor is very high, in general, we have an increase in salaries also. And so these ones here, what they can produce is simply they can produce an excess demand. And for this particular case, guys, in COVID, what we are just ramping up after 1 year of basically having an economic problem. So ramping up implies that the demand is going to be higher than the supply. So this can immediately implies that we have an increase in price. Okay. Well, I think that for this coronavirus case, this is healthy. So this shows that the economy is coming back to normal. This is good. But of course, we need to be very careful about controlling this one here. That should be a temporary one. Once more labor gets into market, perhaps salaries increase, but supply starts catching up. Okay, and so supply increases and demand and tries to reach their demand, and so the prices should stabilize at a given point, and then eventually go back to pre-COVID times. But this is one of the causes of inflation. The other cause of inflation, of course, that this is related, is the supply side of the equation. So what happens if corporations starts increasing in costs? Okay, any type of cost, labor is one of the costs. Perhaps there are some taxes that are going to be there. This is also a cost that they can pass to the customers. But also, if they are importing products from China, let's say, and the costs from China are now higher, normally corporations are going to try to absorb these increases in cost. But there is a point in time that they cannot do that, and they simply move this into the clients. Okay, so and basically, if they do that, if the cost increases in time, not necessarily immediately, because there is competition issues. So you cannot simply pass that complete cost to the client because there are other ones competing with you. So that's why you try to be very careful in the corporation. But there is a point in time in which you cannot do anymore, and also prices can increase. Got it? And the other one that is also all related is what is called the structural one. Okay, this comes more from the world of Keynes, but it was something like that. So imagine that indeed. So this is my P, this is my quantity, and indeed, what the idea is that that the common demand and supply, like an X here. In general, what can happen, and in general, what normally happens is that the supply is aligned. Okay, my demand is like that. No, and then it's going to be aligned until you achieve something that is called the Q price, the Q bar. So this is maximum production or maximum capacity. Okay? So just imagine that you have built already your buildings, your factories, etc., and then you face this demand. Okay? So the price is going to be fixed at this level and for this quantity here. But then if the demand starts moving, it starts increasing for some reason, at the beginning, nothing is going to happen. So the price doesn't increase because you are continuing using from 20% of full capacity to 50% of full capacity. And then the issue is that if this demand starts increasing and there is no increase on capacity of production, there is going to be a point in time in which my supply side, this is my supply, is going to be vertical. Okay? So take a look to if the demand continues moving, there is going to be a point in time in which we are going to cross this part here, and any increase on demand necessarily implies increase on supply. Okay, so that's why I don't know if you have heard about, but in the economy, the economists always say we need to start cooling the economy. We need to do something to slow down the demand, right? Or motivate these guys to create larger factories. But meanwhile, if we are in this part of the equation, so inflation is not a big issue. And this happens in USA. In USA, you have such amount of capacity that basically the inflation is very, very mild. But eventually, if the demand starts increasing, not only American demand, but demand from all over the world for American products, this can happen or not. This is normal. So this is what is called structural way of creating inflation. Okay. I think that with that is a very brief introduction. Inflation is much more complicated than that. It has many or other consequences and causes and problems that it can impose to people. But we just leave it here and just focus on what we try to learn from this class. Okay, so from this class is let's do the math treatment of inflation. So well, let's first of all let's talk a little about measurement. How do we measure? How do we measure this one here? We have technically, guys, three methods. Okay, we have Las Perez. We have another method that is called Pache. I think it's written like that. And then we have Fisher. Okay, so Las Perez is going to be the inflation, let's call it L, is going to be simply sum of, always is P2, P1. So let me delete this one here. So this is the price at period 2 divided by price at period 1. And then here in the Las Perez, we use the original basket of goods. In Apache, what we use is the ending basket of goods. And Fisher basically is simply just multiply L times P and take square root of that. Okay, so these are the three methods of measurement of inflation. So let's take a look to how this works, and just using Excel. So where is this Excel for me? Let me see if I have it open. Yes, I have it somewhere. Inflation, here we go. Just to be sure that I'm showing you this inflation. So this table, guys, shows you how to easily compute an inflation for a specific corporation. Got it? So you can have this information. It is, at least privately available for you as a corporation. You can have month 2, month 3. You have this data from accounting. Okay. So imagine that you know that this is what you consume in month 1, 150, 300 of raw materials, local supplies, foreign supplies. Of course, you can go to the more granular, as you can imagine, energy. And this is the price at period 1. Okay. This is easily available in a corporation, easily. And then in month 2, you realize that you have this consumption, and these are the prices. Right? So you are going to create your own inflation index, your own CPI. Right? And this is crucial, guys, for corporations that really don't resemble the general economy. And this is more or less always. Okay? So what we do is we simply start multiplying P1, Q1, P1, Q2, P2, Q1, P2, Q2, because what we try to do is we try to simply build the indexes that I show you here. You see, that are simply PT, Q1, P1, Q1, etc. Okay, and then we build this one here. And then I simply multiply. This is a very simple process. Is this one? Is this one here? Okay, it's very, very straightforward. And then basically what we do is we construct our last pairs. So last pairs is going to be based on Q1. So it's going to be P2 Q1 is going to be this one divided by P1 Q1. So it's going to be I and H, you see, I and G, sorry, I and G, etc. So what you can observe, guys, here is that Las Peres and Pache, they're very close to each other, and the Fisher, simply you multiply these two and to the power 0.5. And this is your own inflation, and you can use this inflation for forecasting, for project evaluation, etc. Things that we're going to be doing in a couple of minutes. Okay. Now, let's go then into the mathematical treatment of inflation. So let's assume the following, guys. Let's assume that you have period 0. So let's do. Here I have period 1, period 2, and period 3. Let's assume that the inflation of this period here, I call it pi 1, equals 3.5%. This is a lot, but okay. Pi 2 is equal to 4.5%. And pi 3 equals a 5%. Okay. For this period and for this period. So questions here. Now, what is the quarterly inflation? And another question here is, what is the average monthly inflation? Okay, so these are very common questions. Okay, so if we assume that these are months. Well, remember, first thing you need to remember, guys, is that inflation is a compounding interest rate. Okay, inflation is a compounding interest rate. And as such, guys, how do we compute what is the inflation for the quarter? Well, it's going to be 1.035 times 1.045 times 1.05 minus 1. Do you agree? So if you do this, what you're going to get is what? So let me multiply this. So you obtain 13 in percentage term, 13.5654%. So this one here, guys, is your inflation for 3 months. Right? Now, once you have an inflation for 3 months, what they are asking you here is simply telling me what is the inflation for 1 month. So this is a common transformation of compounding interest rates. And we have done that quite a lot. So this is going to be simply 1.135654 to the power of something minus 1. So remember, this goes up. The period goes up. And this one here corresponds to a period of 3 months. So this is the inflation that corresponds to 1 month. So if you do that, you obtain 4.3315%. Done. So this is the way in which we manage inflations. It's a how do you call it? It is simply a compounding interest rate. That's it. It's very, very simple. Now, let's go and see what is the impact of inflation on cash flows, because that's also very important. The impact of inflation on cash flows, or in or cash flows. I'm terrible here. I assume so. Okay, so how this works. Remember, guys, that let's do this in let's do a couple of things. So we have two things. We have current terms. Okay, so this implies this is monetary view. So does not include inflation. So when you talk about current, you are not including inflation. Okay. Also, the current is called nominal. So when you talk about nominal terms, simply implies that you're talking about dollar value. So if I have $100 bill now and I have $100 bill in the future, this is nominal. You don't care about the value, the time value of money. When you talk about, when you want to include the value of money in what you're talking, so this is called real terms. Okay, so real terms includes the effect of inflation. So basically here we're talking about more purchasing power. Yeah. So what is the value, the real value of my money? Okay. Now, in terms of cash flows, guys, let me move to a new graph, new page, so I can use a complete page. Okay, so imagine that we have the following cash flow, okay? And let's do this together. So imagine that I have 1,000 units, and I will have only 3 periods. I have first period, second period, and third period. So I have here, I will receive here 500. I will receive here 600. And I will receive here 700. And assume, guys, remember this is a cash flow, that the opportunity cost real is going to be 5%. So this implies that you want to make 5% real, okay, on top of inflation. That's what I mean. So assume here, guys, the only thing that I will assume here is that the inflation, let's assume that the inflation per period is 10%. Okay, this is a lot, but let's assume just for doing the example. Okay, 10%. Now, these numbers here are nominal numbers. So these are dollar values. right? And I have an opportunity cost that is real. So I cannot technically work, I cannot mix nominal with real. So what I need to do is I need to transform the cash flow that is nominal into real, and then it's going to be real cash flow with real opportunity cost, or I transform my opportunity cost from real to nominal, and then I use nominal cash flow with nominal opportunity cost, right? So let's do these two methods. So, okay, so let's do method one. That is basically, I transform nominal cash flow into real cash flow. And how do I do that? Well, I simply need to deflate. So for this one here, we're going to be using the term of deflation. Okay, simply means extract from each of these cash flows the value, the inflation. So how do we do that? It's a very simple process. So I have my $1,000 here. And these $500 are going to become now, I remove the effect of inflation divided by 1.1. I want to remove the inflation of the 600. So it's going to be divided by 1.1 squared because I have the inflation of 2 periods. And then finally for this guy, I need to remove the effect of inflation that in this case is constant across the board by 103. So if you do this, compute these numbers here. So this one here is going to be 454.54. This is 495.86. And 525.92. Got it? So now these are real terms. You agree? So these numbers are real now. And as soon as this is real, I can use this opportunity cost. And then I can estimate my net present value. I can compute my internal rate of return real. Okay, so I will write this real just to be sure that we understand what we're doing. So if we do this, then my net present value is going to be, as usual, is going to be 1,000. Plus 454.54 divided by 1.05 plus 495.86 divided by 105 squared plus 525.92 divided by 105 cube. Got it? The internal rate of return, you do the cash flow in Excel, and we are going to get a number. I have this number already. But if you do the net present value, guys, the number you're going to get equals 336.98. And if you do the internal rate of return, what number do we get? We get 21.70%. Remember, the rule with the net present value is that if this number here is larger than 0, so this implies that you are better than your opportunity cost, so you do the project. The rule for the internal rate of return is if this number here is larger than the opportunity cost, then you are basically, you are good to go with the project. Okay, so that's it. This is method number 1. It's deflating or simply transforming the nominal cash flow into a real cash flow. Now, the second method, let's call this method 2, is based on the following idea. So when you imagine, guys, that you buy something to sell, okay? So if you buy a pen and you want to sell this pen, what the price should be able to do is 2 things. 1, to allow you to buy back the pen to have something to sell in the future, but also to produce a real profit for you, a markup for you. Okay? So that's why, guys, the current, let me move this one. My current interest rate should be able to cover the cost of the material, so should cover the acquisition value, and also should cover a real interest rate. Agree? So this is to basically buy back the product to sell, to have something to sell in the future, and this is going to be my profit. So this is the basic idea here in this method. And what we are going to do then, guys, in method 2 is what we transform, we compute the rates are going to be now not in real terms, but they are going to be basically in current or nominal terms. Okay? So how do we do that? Okay, let's do the interest per period. So we're going to do the interest for the first period. What is going to be the interest for that we'll be using for the first period, and we need to do this period by period. Okay, this is interest of the first month is going to be my 105. Well, my inflation is 1.10 that multiplies 105. So this is going to be my interest for period 1. This is equal to 0.155. What is going to be the interest rate that I will use for the second period is again 10%. 105. So in this case, all of them are the same. Okay, this is not necessarily the case. And what is the interest rate 3 is going to be 1.1, 1.05, and this is equal to 0.155. Okay. Once I have all the rates, so these are the rates that we'll be using instead of this one here. Once I have the rates in current terms, and my cash flow is in current terms, so I can simply compute my net present value, etc. So what I will be using here, guys, is my current values: 1,000, 500, 600, and 700. So I use the values as they are, because what I will be using now is current or nominal interest rates. And then my net present value, let's call it nominal or current, is going to be minus 1,000 plus 500 divided by the interest rate of the period, 1.155 plus 600 divided by 155 squared plus 700, 1.155 cubed. Then then my internal rate of return current is going to be something. So we're going to do this in Excel. So if you do this, let me see, where do I have this one? Yeah, if you do this, guys, you obtain 36.98. And your internal rate of return is going to be 33.8750. Okay, as you can see here, two things to note here. The net present value, guys, doesn't matter which method do you use, it's always going to be the same. Okay, another point in favor of net present value, guys. As I was telling to you, we normally use net present values always. Okay, the internal rate of return, you need to be very careful. Well, in this particular case, guys, in which inflations are exactly the same per period, okay, please pay attention. If and only if the inflation rate is constant per period, we can move from the internal rate of return that is real to an internal rate of return that is current using this formula. Okay, again, I can use this formula just to recover the current internal rate of return from the real internal rate of return if and only if the inflation rates are constant across all months. Okay, and how do I do that? Take a look to the formula. Yeah, I will do this here. My internal rate of return current should be equal to 1 plus pi, 1 plus internal rate of return real minus 1. Okay, so if we replace values, this is 1.1 because inflation is constant. That multiplies 1.2170 minus 1. And then for sure, what you're going to obtain here, guys, is a 33.8750. Okay. Remember again, this happens if and only if inflation per period is exactly the same in all the periods. Okay, so but if you have a different number here, you're going to see that you're not going to get anything. Okay, so let's try. Let me save this one here, and let's see this in Excel. Okay. What is the value that I'm using? Nope. Yes, this is the example I'm using. So we receive a cash flow of 1,000, 500, 600, and 700. Inflation is equal per period. You see that? And then the first method, I need to deflate. So what I need to do is I need to do this first number divided by 1.1. This second number, 600 divided by 1.1 squared. So this is squared. A6 is squared. Oh, you know what? Let me modify the formulas here. This is correct. This is correct, and this is correct. Yeah, these are the formulas. Got it? So what I've done is what I've done by hand in the screen. So I simply deflate the cash flows. Once I deflate the cash flows, all these ones here, guys, are in real terms. So now I can use my opportunity cost that is real. I do my net present value as usual. Remember, the net present value only, when you use the NPV value, guys, you only capture the values that go from 1, so the future, to the end. So you will only consider this one in the NPV function. And then you sum the first one, the one that is in periods here. Remember that, that's crucial for using the NPV in Excel. So my net present value is 336.98. My real IRR, so simply do IRR of this block, is 21.70. Now, if we do the current method, as I told you, this is I need to have the real plus inflation. So I need to cover my profits and I need to cover my acquisition cost, my purchasing power. What I do is I need to compute the interest per period. Okay, so it's going to be I think it's 1.5 times E17. No, sorry. It's going to be the inflation, each period inflation times this one here, each period inflation times this one here, each period inflation times this one here. And this is, in this case, these are the same because inflations are constant across all the months. And once you have that, these are current interest rates, current or nominal interest rates, and then you simply use these ones here to compute each of the values here. The formula gets now kind of what's going on? Oh yeah. So this is my nominal or current cash flow. So it's the same as the original one. And then you simply here, you compute the net present value. Got it? As usual. So you simply say this one here, in this case, you can use the net present value formula because B28 is the same for all of them. Okay, you're going to see how this gets a little more complicated when the inflation rate is different, and because of that, these numbers are going to be different. In that case, you cannot use the Excel formula. But for this particular case, I can use my Excel formula as soon as all my rates are the same. So I can use the NPV formula, P28. I'm using just the first one. And it's okay because all the other ones are the same. And then you can see, guys, the net present value real is exactly the same as this one here. The internal rate of return looks different. However, they are equivalent. And we can recover one from the other because inflation rates are constant across all the months. So it's 10, 10, 10. If I have 10, 8, 7, we cannot do that. Okay, that's why using the internal rate of return is again kind of misleading sometimes. And then we do that. What I've done here is simply 1 plus real, 1 plus inflation is going to be my constant. Okay, and then you can see if I use this one here, 1.21 multiplied by 1.05, you obtain the 33.87% that is this one here. Okay. Now, what happens, and this is the next case, what happens, guys, when the inflation is different? Okay, inflation per period is different. So let's take a look to this example. I have, let me move this a little more. Yeah, perhaps a little more. So we have these cash flows. We have $6,000, and then we're going to receive $3,000 and $5,000 in the future. Okay. So first method, deflate the cash flow. So what I'm doing is I'm dividing 3,000 divided by 105. And then the next number is going to be 5,000 divided by 105 and times 108. So you know what? Let's do this first. I think by pen. So let me look for this example so I can use the numbers here. Yeah, I can use the numbers here. So let's do this by hand first, just to be sure that we all understand what we are doing, what we do. And then Excel is going to be very simple. So let's assume the following. So I have a cash flow. I have a cash flow that looks like this. I invest $6,000. I only have 2 periods. One period I receive $3,000, and the other period I receive $5,000. Okay, so this is period 1, period 2. My opportunity cost real is going to be equal to 10%. Okay, and my inflation here, inflation period 1 is going to be 5%. Inflation in period 2 is going to be 8%. Okay, so here you can see, guys, that inflation rates per periods are different. So we cannot recover the internal rate of return current versus using the internal rate of return real. We cannot do that. Okay. Now, so let's do method 1 again. So it's basically deflating. And deflating means simply, okay, so my $6,000 are here. What I need to do is I need to move this money. This number is going to be $3,000 divided by 105. And this number here is going to be $5,000 deflated one period, 108, and deflated another period, 103. So the order doesn't matter because it's a multiplication, but 105. 105. I'm simply deflating this one here and deflating here. Got it? So if you compute these numbers, this number here is going to be equal to 2857.14. And this number here is going to be 4409.17. Got it? So now this is real opportunity cost. We simply use the net present value technique. Net present value, let's call it real, is going to be equal to $6,000 plus 2857.14 divided by 1.1 plus 4,409.17 divided by 1.1 squared. Now, if you compute this number here is going to be 241.35. If you compute your internal rate of return real, guys, using Excel, this is going to be 12.78%. And then we are done with this method. Now, if we use method number 2, okay, so in that case, what I need to compute is what is the interest rate per period. So the current interest rate for period 1, so these are current, remember that, is going to be equal to my inflation, 105 times 101 minus 1. And the interest rate, current interest rate that I will use in the second period is my inflation here is 108 times 101, 1.1 minus 1. And should I get what? I get here, I get here 15.5%. And in Excel, I get 18.8%. Got it? So now when we have these interest rates that are current, I can use my current cash flow. So I basically use the original one. I use this one, I'm sorry, 3,000 and 5,000. And then I simply use my techniques. Net present value is going to be current or nominal. Is going to be equal to minus 6,000 plus 3,000 divided by 1.155. So this rate here, this is the rate for period 1, plus 5,000 divided, I need to update 1 and 2. So the first rate is going to be 1.188, and the second rate is going to be 1.155. And if you do this, guys, what you obtain again is going to be 241.35. And if you do the internal rate of return current, the internal rate of return current, guys, is 19.65%. Now, the issue, as you can see again, and that's what is beautiful about the net present value. The net present value, it doesn't matter if you use method 1 or method 2, they are going to be exactly the same. However, the internal rate of return, guys, which one do you use? There is no way you can use the formula to transform this one here, to move from here to here, because I have different inflations per period. So that's why when you have inflation involved, guys, what we use normally is this method here, and we use the net present value of the decision rule. Okay, and always the net present value is the safest technique to use in project evaluation. All right, so let's do Excel. Let me show you Excel, how this works. Once you understand that this part is very easy here. So we have my cash flows. This is my real cash flow. When I deflate, so I use 3,000 divided by 105, 5,000 divided by 105 times 108. Then you can see 241, 1278. If I use the current one, so what I do here, remember, let's take a look to one, is simply multiply the inflation times the opportunity cost, 105 times 101. This is the first one. And the second one is going to be 108 times 101 minus 1. And then you get 18%. So these are current terms. This is a current cash flow. And here's what I was telling to you guys. You cannot use anymore the PMT function of Excel, because the PMT function of Excel requires a single discount rate. We don't have a single discount rate anymore. So that's why we need to create our own formula. So this is going to be what I written in here. This one here is exactly what is in Excel. Okay, just to be sure about that. So here we have B26 is going to be minus $6,000 plus $3,000 divided by 1 plus B23, basically 1.15. This is the first cash flow. The second cash flow is going to be $5,000, 1 plus 24. This is 1.18 times 1.15. And then that's it. This is what we have done in writing. You have the 241.35, and then you have internal rate of return of 19.61. So these are the two, they are equal, etc. Okay, guys, so this is for today's class, and I will provide you with PDFs of these ones here. So I want you to do them. I want you to really solve each of these problems, replicating these problems. You have the solutions, but you need to do them. You need to use the formulas, and etc., etc., etc. Got it? Okay, I will post this video as soon as possible. Thank you, guys, and have a great weekend. Bye-bye.